Okay, welcome to Chapter 9, Water Resources. We're going to go through this, and this is about where our water is and what water we have available. Water pollution will come later and is highly related to this, but we're going to just go through this right now. It's a rather short chapter. The fact is that over 97% of the water on our planet is in the ocean, and that means it's salty, which means we can't use it, not straight up. And yes, we can do what's called desalination. I'll talk about that in a little while, but that's a very, very expensive and difficult process to accomplish. So about 3%, a little less than 3% of the water on our planet is fresh water. Of that 3%, most of that occurs in ice and glaciers in areas where humans are not. So very little of the water, really less than 1% of the water we have on this planet is available for us to use in our groundwater and in our surface water, our lakes and stuff, which is a huge problem. We have a huge use of water for industry, for residential, and for agriculture. And the fact that there's very little water available is a very big problem. And honestly, water is going to become a bigger and bigger issue as our population and our industries and agriculture continue to grow. Okay, so most of our water that we can use is found in our groundwater or our aquifers. An aquifer is a permeable rock layer underground, usually in limestone or sand and gravel. And most of our aquifers that you're going to talk about or you know of here in Florida are what we call unconfined aquifers, which means they occur just below the surface. And they recharge, which means when we get rain, if it doesn't evaporate and the plants don't use it, it will actually percolate its way down into the groundwater and recharge it, refill it up. So it's like there's a constant source of water refilling, or we want there to be a constant source of water, refilling those aquifers. So as we're pumping water out for whatever we need it for, it's being filled back up every time it rains, kind of thing. The problem is, in a lot of these areas, those are called recharge zones, okay? So basically all of Florida is a recharge zone. But if you go and pave over those recharge zones with parking lots and school beaches and those kind of things, you're blocking that recharge. And so you'll reduce the recharge rate, and that can have a huge consequence. So they're starting to develop more permeable cements and asphalts and stuff that will allow water to percolate through, and that would be hugely advantageous for us because that would help recharge those aquifers. There are some aquifers that are what we call a confined aquifer, which means they occur below a impermeable rock layer, which means they don't have a recharge at all, or it's very, very little recharge in that that occurs. The problem with a confined aquifer, and one of the biggest aquifers in the United States is a confined aquifer that we're currently using. And I can't remember the name of it offhand. That means that once it's empty, it's empty. It's not getting refilled up, so it's empty. It's a limited source of water, and it's going to run out, which is a huge issue. So here you have your unconfined aquifer. It's your water table. If you have a well, it's what your well goes into. Confined aquifers, again, a little recharge zone or none at all, but basically no real recharge in those, so they are going to run out. Oh, by the way, it's not open like that. It's not like this blue layer. There's gravel and rock and stuff in there. It's kind of empty, but it's not that empty. Okay. And actually, as our aquifer decreases, that's when we get sinkholes, because that water's not there supporting our soil above it. So we'll be right back. Okay. So water table is the surface of that groundwater above us. If the water table dips, that could increase our chances of sinkholes, and if your well's not deep enough, your well could run out of water. Sorry. Groundwater recharges, again, the water percolating through the soil down into the aquifer to recharge it. Recharge zones are highly, highly, highly important. Springs are areas where water from the aquifer is reaching the surface. We have lots of springs here in Florida because we have lots of aquifers. So if you go to Crystal Springs or Blue Springs and stuff like that, that's where your aquifer water is percolating out. And of course, when we went on our field trip, you guys saw that a lot of our spring water comes out, and that's where the Hillsborough River really increases in size because of the spring water, not because of runoff. Our artesian well is just an opening where, because of pressure, water is coming up. The fountain of youth is supposed to be an artesian well kind of thing. Okay, a couple things you need to know. What happens when we overuse water? If you are pumping out a lot of groundwater, aquifer water, two possible things can happen. Two bad things can happen. The first one is called the cone of depression. And that's when you're pumping out a lot of water, like if you look at the picture there. One well is deeper than the other, and it starts pumping out a lot of water. It can actually decrease the amount of water in your aquifer, and it will actually kind of pull the water down into it, and it makes what we call a cone of depression, and can cause other smaller, less deep wells around it to go dry. So that's your cone of depression. You're just going to really irk your neighbors. Kind of thing. The other one is what we call saltwater intrusion. If your flow of water, all aquifers end up in the ocean. They all feed out to the ocean. If your flow in your aquifer is not a positive flow, in other words, water is not flowing out of it into the ocean, then saltwater can intrude back in. If it's not going out, then saltwater will head in. The fresh water is not going out. And you can get saltwater intrusion, and you can get saltwater contamination of your aquifer, which is a hugely big deal. So we really have to, especially around our coastal areas, we got to watch that we are not pulling out so much water that you can actually get saltwater intrusion. We do not want saltwater in our aquifer. That would, of course, contaminate our aquifer, and salt is a very deadly thing to plants and animals, so we don't want that occurring. So two possible negative things occur when you overuse water in your aquifer, and that is the cone of depression and saltwater intrusion. You need to know those. Okay, so surface water. Where is our surface water? By volume, the Caspian Sea is the largest source of fresh water. For depth, it's Lake Baikal. I can't see those. I need my glasses. I have my glasses on. I can't see it. And then by surface area, Caspian Sea. Those are just some fun things to know, kind of thing. Occasionally, one of your multiple choice of questions on the AP exam might be some kind of crazy thing like that, like which is the deepest lake in the world? Well, now you know. It's Lake Baikal. Okay. Floodplains. Floodplains occur around rivers. Floodplains are a naturally occurring thing, and they're very, very important. They reduce flooding. So your river is flooding, and water runs out onto the floodplain, and it deposits a lot of good nutrient-rich sediment onto these floodplains. These floodplains end up being a place where we like to do agriculture. Unfortunately, too, because rivers give us a good way of transporting goods and stuff, many of our large cities occur along rivers in areas that are really flood zones. So that's why you hear in the spring about all these places flooding along the Mississippi and other large rivers and all, because they built on a floodplain. Guys, don't build on a floodplain. Doing your agriculture on a floodplain is fine. Your crop gets flooded, not a big deal. Your house, that's a big deal. And you hear about these same areas flooding year after year after year, and that's because they're on a floodplain. It's made to flood. It's supposed to flood. It's a good thing that it floods, but you don't want to build on a floodplain. We've talked a little bit about eutrophication. I'm not going to get into it really heavily here until we get to pollution. At least I don't think I am. When we talk about lakes, there's 3 different stages of lakes. Oligotrophic lakes are very low nutrient lakes. All the nutrients are tied up in the organisms, in the plants and animals. There's very little nutrients in the water. That is a healthy lake. Oligotrophic is a healthy lake. Mesotrophic is when there's a moderate level of productivity in the water. In other words, there's some nutrients in the water. So a little bit of contamination. Not really bad, but a little, going to be a little green maybe at times, that kind of thing. Eutrophic. Eutrophic is when we have a high level of nutrient contaminant. Lots of nitrogen, phosphorus is getting in the water from sewage, from fertilizers, from whatever source there is, and it causes algal blooms. It's a sick lake. The algal blooms bloom, they use up all the nutrients, they die, they get decomposed by the bacteria who uses up all the oxygen to do the decomposition because they're heterotrophic like we are, and then all the little fishies go belly up. It's a bad, bad, sick lake. Almost every lake in Florida is eutrophic. And that's because we use a lot of fertilizers. And that fertilizer runs off. So eutrophic is bad, oligotrophic is good. That's what we want. And then mesotrophic is in between. Okay. So we do a lot of things to move water around. Put water where we want it to be rather than where it is. Levees are built along sides of rivers to keep them from flooding areas. Dikes are to keep salt water out, so that's the only difference between them. They're basically big berms kind of thing to keep them out. Levees is for freshwater, dike is for saltwater. It's just a different name, but basically the same thing. In lots of these around New Orleans, of course, because New Orleans is actually below sea level, and this is what failed. The dikes and levees failed during Hurricane Katrina, and that's why all the flooding occurred in the city. A dam, we usually create dams for two reasons, primarily to create electricity, but it also creates a reservoir of water behind it, so it stores water for us. So that can be also good. In areas that don't have a lot of water, you might want to store that water rather than letting it run down into the ocean. With regards to dams, fish ladders are a big deal. They help organisms like salmon get around the dam, but they're not that great. There's not a very high percentage. Yeah, we'll talk more about dams in class a little bit, but fish ladders, they're effective, but not very great. We also create things like aqueducts, which are basically man-made rivers that transport water. Lots of these in California, transporting water in from other states. Highly ineffective. Lots of evaporation occur. Because they're open, they're going through hot areas like the picture shows. Lots of evaporation, lots of water loss. They're not very effective, but they're one way to get water from point A to point B. Another way to get water is desalinization. There's basically two ways to do desalinization. A distillation method where you heat it up and the water evaporates and then you condense it and it's fresh water. And then the salt remains and you get rid of the salt and you have fresh water. Difficult process, high contamination rate problem. Reverse osmosis, forcing water through a membrane that only allows the water through, is a much better thing, but requires a lot of energy to occur. Both of these require a great degree of energy, so they're not very cost effective. The only country who does this on a large scale very effectively is Saudi Arabia, because they kind of have to, but they have lots of money to back it up, so it's not so bad. Number one use, I'm going to run through these really fast because I only have a minute left. Number one use for water is agriculture. So number one, the reason we use it for irrigation. There's different types of irrigation. When we talk about agriculture, we'll talk about the different types of irrigation and their effectiveness, but they're here as well. Drip irrigation, of course, is the most effective. Anyone that's coming out of the sky is going to have a high evaporation rate, so that's an issue. Industry, that is a nuclear power plant. We use water to cool that process. That's all steam coming out. That's another big one. We use a lot of water to make things. And then households. Flushing our toilet is number one. We use a lot of water in our households, probably more than we need to. But now you can get, low flow toilets, low flow shower heads, those kind of things, which is good. And then in the future, we need to make sure we're doing more native landscaping so you don't have to water it much. And this is called a xeriscape there. Planting what's native is a good thing. Okay, so we'll talk about this in class. I'll see you guys later. That is chapter 9. We're all done.